0.0665 kilogram M2 /S3 Sinsk equals 9.80665 M /S2 almost equal to 745.700 Since 1 W1J /S equals 1 N M /S equals 1 kilogram M /S2 M /S, or given that 1 HP equals 550 foot lbf /S, 1 foot equals 0.3048 m, 1 lbf almost equal to 4.448 n, 1 J equals 1 nm, 1 W equals 1 J /S, 1 HP almost equal to 746 W metric horsepower. PS, CV, HK, Park, KS, CH. 1 metric horsepower is needed to lift 75 kilograms by 1 meter in 1 second. The various units used to indicate this definition: PS, kilometer, CV, HK, Park, KS and CH, all translate to horsepower in English. British manufacturers often intermix metric horsepower and mechanical horsepower depending on the origin of the engine in question. DIN 66036 defines 1 metric horsepower as the power to raise a mass of 75 kilograms against the Earth's gravitational force over a distance of 1 meter in 1 second. Sad Smiley 19. 75 kilogram 9.80665 M /S21 M /1S equals 75 kg FM /S equals 1 PS. This is equivalent to 735.49875 W, or 98.6% of an imperial mechanical horsepower. In 1972, the PS was replaced by the kilowatt as the official power measuring unit in EEC directives. 20. Other names for the metric horsepower are the Italian cavallo vapor, CV, Dutch pedonkracht, Park, the French cheval vapeur, CH, the Spanish cavallo de vapor and Portuguese cavallo vapor, CV, the Russian, the Swedish Hastkraft, HK, the Finnish Hevosvoima, HV, the Estonian Hobajud, HJ, the Norwegian and Danish Hestekraft, HK, the Hungarian LE, the Czech Kosksyla and Slovak Konskasila, K or KS, the Bosnian /Croatian /Serbian Konjska Snaga, KS, the Bulgarian, the Macedonian, KC, the Polish Kon Mechaniczny, kilometer, Slovenian Konjska Mo, kilometer, the Ukrainian, the Romanian Kalputeria, CP, and the German Ferdistik, PS. In the 19th century, the French had their own unit, which they used instead of the CV or horsepower. Based on a 100 kg FM /S standard, it was called the Poncelet and was abbreviated P. Tax. Horsepower. Tax or fiscal horsepower is a nonlinear rating of a motor vehicle for tax purposes. 21. Tax horsepower ratings were originally more or less directly related to the size of the engine, but as of 2000, many countries changed over to systems based on CO2 emissions, so are not directly comparable to older ratings. The Citroën 2CV is named for its French fiscal horsepower rating, Deux chevaux, 2CV. Electrical horsepower. Nameplates on electrical motors show their power output, not the power input, the power delivered at the shaft, not the power consumed to drive the motor. This power output is ordinarily stated in watts or kilowatts. In the United States, the power output is stated in horsepower, which for this purpose is defined as exactly 746 W. 22. Hydraulic horsepower. Hydraulic horsepower can represent the power available within hydraulic machinery, power through the downhole nozzle of a drilling rig. 23. Or can be used to estimate the mechanical power needed to generate a known hydraulic flow rate. It may be calculated as 23, where pressure is in psi, and flow rate is in US gallons per minute. Drilling rigs are powered mechanically by rotating the drill pipe from above. Hydraulic power is still needed though, as 1500 to 5000W are required to push mud through the drill bit to clear waste rock. Additional hydraulic power may also be used to drive a downhole mud motor to power directional drilling. 23. When using SI units, the equation becomes coherent and there is no dividing constant. Where pressure is in pascals, Pa, and flow rate is in cubic meters per second, M3. Boiler horsepower. Boiler horsepower is a boiler's capacity to deliver steam to a steam engine and is not the same unit of power as the 550 feet-pound /s definition. 1 boiler horsepower is equal to the thermal energy rate required to evaporate 34.5 pounds, 15.6 kilograms, of fresh water at 212 degrees Fahrenheit, 100 degrees Celsius, in 1 hour. In the early days of steam use, the boiler horsepower was roughly comparable to the horsepower of engines fed by the boiler. 24. The term boiler horsepower was originally developed at the Philadelphia Centennial Exhibition in 1876, where the best steam engines of that period were tested. The average steam consumption of those engines, per output horsepower, was determined to be the evaporation of 30 pounds, 14 kilograms, of water per hour based on feed water at 100 degrees Fahrenheit, 38 degrees Celsius, and saturated steam generated at 70 psi, 480 kPa. This original definition is equivalent to a boiler heat output of 33,485 2/H, 9.813 kilowatts. A few years later in 1884, the ASME redefined the boiler horsepower as the thermal output equal to the evaporation of 34.5 pounds per hour of water from and at 212 degrees Fahrenheit. This considerably simplified boiler testing, and provided more accurate comparisons of the boilers at that time. This revised definition is equivalent to a boiler heat output of 33,4692/H, 9.809 kilowatts. Present industrial practice is to define boiler horsepower as a boiler thermal output equal to 33,475 2/H, 9.811 kilowatts, which is very close to the original and revised definitions. Boiler horsepower is still used to measure boiler output in industrial boiler engineering in the US. Boiler horsepower is abbreviated BHP, not to be confused with brake horsepower, below, which is also abbreviated BHP. Drawbar power. Drawbar power, DBP, is the power a railway locomotive has available to haul a train or an agricultural tractor to pull an implement. This is a measured figure rather than a calculated one. A special railway car called a dynamometer car coupled behind the locomotive keeps a continuous record of the drawbar pull exerted, and the speed. From these, the power generated can be calculated. To determine the maximum power available, a controllable load is required. It is normally a second locomotive with its brakes applied in addition to a static load. If the drawbar force, F, is measured in pounds force, lbf, and speed, v, is measured in miles per hour, then the drawbar power, p, in horsepower, hp, is example, how much power is needed to pull a drawbar load of 2,025 pounds force at 5 miles per hour. The constant 375 is because 1 HP equals 375 lbf miles per hour. If other units are used, the constant is different. Willising coherent SI units, watts, newtons, and meters per second, no constant is needed, and the formula becomes P equals FV. This formula may also be used to calculate the power of a jet engine, using the speed of the jet and the thrust required to maintain that speed. Example, How much power is generated with a thrust of 4,000 pounds at 400 miles per hour, RAC horsepower, taxable horsepower. This measure was instituted by the Royal Automobile Club and was used to denote the power of early 1900s British cars. Many cars took their names from this figure, hence the Austin 7 and Riley 9, while others had names such as 40/50 HP, which indicated the RAC figure followed by the true measured power. Taxable horsepower does not reflect developed horsepower, rather, it is a calculated figure based on the engine's bore size, number of cylinders, and a, now archaic, presumption of engine efficiency. As new engines were designed with ever-increasing efficiency, it was no longer a useful measure, but was kept in use by UK regulations, which used the rating for tax purposes. The United Kingdom was not the only country that used the RAC rating. Many states in Australia used RACHP to determine taxation. 25, 26. The RAC formula was sometimes applied in British colonies as well, such as Kenya, British East Africa. 27, where D is the diameter, or bore, of the cylinder in inches, N is the number of cylinders. 28, since taxable horsepower was computed based on bore and number of cylinders, not based on actual displacement, it gave rise to engines with under-square dimensions. Bore smaller than stroke, we tended to impose an artificially low limit on rotational speed, hampering the potential power output and efficiency of the engine. The situation persisted for several generations of 4 and 6-cylinder British engines. For example, Jaguar's 3.4-litre XK engine of the 1950s had 6 cylinders with a bore of 83 mm, 3.27 in, and a stroke of 106 mm, 4.17 in. 29, where most American automakers had long since moved to over-square, large bore short stroke, V8 engines. See, for example, the early Chrysler Hemi engine. Measurement. The power of an engine may be measured or estimated at several points in the transmission of the power from its generation to its application. A number of names are used for the power developed at various stages in this process, but none is a clear indicator of either the measurement system or definition used. In general, nominal horsepower is derived from the size of the engine and the piston speed and isonly accurate at a steam pressure of 48 kPa, 7 psi. 30, indicated or gross horsepower, theoretical capability of the engine, plan /33,000, minus frictional losses within the engine, bearing drag, rod and crankshaft windage losses, oil, film drag, etc., equals brake /net /crankshaft horsepower, power delivered directly to and measured at the engine's crankshaft, minus frictional losses in the transmission, bearings, gears, oil drag, windage, etc., equals shaft horsepower, power delivered to and measured at the output shaft of the transmission, when present in the system, minus frictional losses in the universal joint /S, differential, wheel bearings, tire and chain, if present, equals effective, true, THP, or commonly referred to as wheel horsepower, WHP. All the above assumes that no power inflation factors have been applied to any of the readings. Engine designers use expressions other than horsepower to denote objective targets or performance, such as brake mean effective pressure, MEP. This is a coefficient of theoretical brake horsepower and cylinder pressures during combustion. Nominal horsepower. Nominal horsepower, NHP, is an early 19th century rule of thumb used to estimate the power of steam engines. 30, it assumed a steam pressure of 7 psi, 48 kPa. 31, nominal horsepower equals 7 area of piston in square inches equivalent piston speed in feet per minute /33,000. For paddle ships. The Admiralty rule was that the piston speed in feet per minute was taken as 129.7, stroke, 1 /3.38.30, 31, for screw steamers. The intended piston speed was used. 31. The stroke, or length of stroke, was the distance moved by the piston measured in feet. For the nominal horsepower to equal the actual power, it would be necessary for the mean steam pressure in the cylinder during the stroke to be 7 psi, 48 kPa, and for the piston speed to be that generated by the assumed relationship for paddle ships. 30. The French Navy used the same definition of nominal horsepower as the Royal Navy. 30. Comparison of nominal and indicated horsepower. Ship indicated horsepower, IP, nominal horsepower, NHP, ratio of IP to SAUR CD 2722001.36, 30, Locust 1571001.57, 30, Radimanthus 40022001.82, 30, Albacore 109601.82, 31, Porcupine 2851322.16, 30, Harpy 5202002.60, 30, Spitfire 380140.2.70, 30, Spiteful 7962802.85, 31, Jackal 4551503.03, 30, Supply 265803.31, 31, Simon 1,5764003.94, 31, Hector 3,2568004.07, 31, Agincourt 6,8671,3505.08, 31, Bellerophon 6,5211,0006.52, 31, Monarch 7,8421,1007.13, 31, Penelope 4,70360007.84, 31. Indicated horsepower. Indicated horsepower, IP, is the theoretical power of a reciprocating engine if it is completely frictionless in converting the expanding gas energy, piston pressure displacement, in the cylinders. It is calculated from the pressures developed in the cylinders, measured by a device called an engine indicator, hence indicated horsepower. As the piston advances throughout its stroke, the pressure against the piston generally decreases, and the indicator device usually generates a graph of pressure vs stroke within the working cylinder. From this graph the amount of work performed during the piston stroke may be calculated. Indicated horsepower was a better measure of engine power than nominal horsepower, NHP, because it took account of steam pressure. But unlike later measures such as shaft horsepower, SHP, and brake horsepower, BHP, it did not take into account power losses due to the machinery internal frictional losses such as a piston sliding within the cylinder, plus bearing friction, transmission and gearbox friction, etc. Brake horsepower. Brake horsepower, BHP, is the power measured using a brake type, load, dynamometer at a specified location, such as the crankshaft, output shaft of the transmission, rear axle or rear wheels. In Europe, the DIN 70020 standard tests the engine fitted with all ancillaries and exhaust system as used in the car. The older American standard, SAE gross horsepower, referred to as BHP, used an engine without alternator, water pump, and other auxiliary components such as power steering pump, muffled exhaust system, etc., so the figures were higher than the European figures for the same engine. The newer American standard, referred to as SAE net horsepower, tests an engine with all the auxiliary components. See engine power test standards below. Brake refers to the device which is used to provide an equal braking force /load to balance /equal an engine's output force and hold it at a desired rotational speed. During testing, the output torque and rotational speed are measured to determine the brake horsepower. Horsepower was originally measured and calculated by use of the indicator diagram.